Hello everyone, today we'll introduce you how to design applications on the YY3568 development board. Before we start, let's briefly introduce you to our development board. YY3568 is a development board with our K3568 core. According to a new design, it has the characteristics of low power consumption and high performance. The development board has an extensive interface and supports multiple external sensor modules. Therefore, it is widely used in boundary computing and smart home, such as smart cars. Let's enter the official website first. Open the introduction about the serial port. The general serial ports marked here as serial ports 3, 4, 8, 9. There is a silk screen mark on the back of the development board. Serial port 2 is a debugging serial port, not recommended for other purposes. Today we are making a serial port loopback test. The TextD and ArcsD of serial port 4 need to be connected with a bridge. Thus, a sent data will be returned to the receiving end unsealed. Here are the 5 APIs of the serial port and the test code. To introduce them, I copy them to VS Code. Let's start with the 5 API functions. First, open the serial function. The parameter is the serial port number. Can be selected in serial port 3, 4, 8, 9. If the serial port is opened successfully, it will return the file descriptor. With the serial port, this file descriptor is very important. It represents the serial port you've opened, whether you are setting the baud rate or sending and receiving data. This descriptor is needed, otherwise, the operation object cannot be confirmed. This is the function to set the baud rate, data bits, stop bits, and parity. The parameters are selected according to the actual situation. This is the function to read data from the serial port. In addition to giving it the file descriptor, you also need to give it the address where the data is stored. The last parameter is the length of the read data. This is the function to write data to the serial port, in addition to the required data sent with a const modifier. The parameters are basically consistent with the read function. The purpose is to prevent the function from modifying a sent data. Ensure data security. Finally, close the serial port function. The parameter is a file descriptor. Now let's look at the example. The header file is missing from the sample on the official website. If you fail to compile using this sample, it is likely that the header file was not added. Let's start with the main function. The main function has only one API test function here. Let's have a look. For easy reading, I fold the function segment of if ft-redo. These feature segments after an API call fails. Printing tips. If you have problems during debugging, the source of the problem can be determined according to these prompts. These two are an array of characters used to store and receive data. First, set them all to 0. Set from 0 to 4 here to send 5 data. 0 times 30 is the character 0. In the ASCII code table, each cycle adds I and the corresponding position. In the array will store the corresponding data. Open serial port 4. If the opening is successful, F is the serial port file descriptor, then set the baud rate of serial port 4 to 115,200. 8-bit data bit, 1-bit stop bit, no verification code. Start sending data. When setup is completed, calling fsync ensures that the data sent to the serial device is up to date. Guaranteed reliable data transmission with a delay of 0.2 seconds. Wait for the serial port to be sent. Start receiving data after sending data. After receiving, close the serial port 4. Then compare the sending and receiving data through the memp function. Print buff write buff read same if the data arrives. Otherwise, print buff write buff read diff and receive data. In short, the serial port loopback test is the same serial port device for data transmission. Finally, compare whether the sent and received data have arrived. Let's execute the code. Always use a bridge to connect the transceiver of serial port 4 before executing. This is the executable file that the code gets after compiling. Execute. You can see the words buff write buff read same. Prove that serial port 4 is working properly. Certainly, if you want to run a serial loop test using the command Detailed tutorials are also available on the official website. That's all for today. If you want to know anything about the YY3568 development board, leave your comments below.